Well, hello Internet, and welcome to my new and improved C++ tutorial. To celebrate getting to 1 million subscribers, I decided to remake my most popular video. This is basically a 1,000+ page book all crammed into one video. You can find underneath the video a table of contents to jump to exactly what you want to learn. In the description is a link to all the code, as well as an installation video if you want to have the exact same setup as me, and I have a lot to do, so let's get into it. Alright, so everything here is going to work exactly the same on Windows as well as on Mac and Linux and everything. I decided to use NetBeans because it's very easy to install, and what we're going to do to start off is go to File and New Project. I'm going to pick that I want a C++ application, click on Next. I'm going to call this CPP Tut. Click on Finish. Make sure I have C++ 14 selected here. Everything else should be fine. Make sure you have a check mark here where it says, do you want to generate a main file? And click on Finish. Now what you're going to want to do is go over here where it says CPP Tut. Click on Source Files, and here is main CPP. Open that up by right-clicking on it and clicking Open. We can close this start page, and here is everything. We are going to delete all of this stuff. This is how you make a multi-line comment, by the way. Just put a / and a star, and then a star, and then a closing slash. All other comments are just going to start with 2 / and comment, or whatever you want to say after it, obviously. This right here is going to allow us to import the C standard library. And it's going to contain functions for converting from different data types to another, random number generation, memory management, searching, sorting, and a whole bunch of other general purpose functions. We're also going to include a whole bunch of other different libraries, and I'm going to walk you through what all of them do, and of course in examples down below I'm going to cover in detail. Also going to get the IOStream library, which is going to allow us to read and write data. I'm also going to get string, which is going to allow us to work with strings. I'm going to get limits, which are going to provide functions so I can show you the min and max values for data types. Vector, so I can work with vectors, which I will explain in detail later. Stream, which is going to allow me to work with string streams, which I'll cover later as well. Numeric, which is going to allow me to work with sequences of values. CTime, which is going to allow me to work with time. CMath, which is going to provide a ton of common math functions. And for now, I think that's going to be it. That brings us to using namespace standard. Let's go and create a hello world program here. Now, if this guy wasn't here, what I'd have to type is std and cout. Cout allows us to output information to our console. And I could just go like this and then follow that up with hello world and end that with endl and a semicolon. This guy right here is known as the stream insertion operator. And what it's going to do is take this string that you have right here and it's going to put it into the cout stream, which is going to display it on your screen. And then finally here we have endl, and what it's going to do is both issue a new line as well as force a write to our console. But since I have using namespace standard right here, what I can do is get rid of this, because this line of code right here is saying that we want to use the standard namespace, which basically just means that we can avoid typing in standard every single time. And if we save this and run it, you can see hello world pops up right here. I'm going to take this output window and I'm going to drag it over here to the right side of my screen and drop it, and now we'll be able to see all that. And then I'm going to open up the main CPP file. This function right here, which is main, is where all of our execution of our code is going to begin, and these parameters inside of it are going to be used for a couple different things. The first one right here is going to tell our main function the number of arguments that are going to be passed inside of it. And then this one right here is going to be an array of pointers to strings. Again, I'll cover all of this in more detail as the tutorial continues, or you can click in the table of contents to search out and learn about all the individual different parts. And this int right here at the very beginning of main is saying that the main function is going to return an integer whenever it is done executing. And an integer is just a value that doesn't have decimal places. And you can see right here with the return statement that that is exactly what it is doing, returning an integer, that integer being 0. More specifically, whenever a program executes without an error, the main function is going to return a 0. Now, any variables which are just names associated with values that are going to be declared outside of any function, main being the only function we have right now. So if we would declare a variable, which is an integer, and I could call this I'm global and give it a value of 0, this is what we call a global variable. And it is available, and its values more specifically is available in any of the functions or any of the code that reside in this individual file. If you would like to create a constant, which is a variable whose value cannot change, just type in const. I'm saying this is a double, which means that this is going to be a value that does have decimal places, and I could type something like 3.141, for example. Okay, so now let's talk about variables and data types. A variable's name can contain letters, numbers, underscores, but not math operators or spaces, and they cannot start with a number. Now, there are numerous different data types available to us, and basically a data type just defines how much memory to set aside for the data we want to associate with its name. Booleans, which you define with bool like that, followed with a variable, can have a value of true, or the number 1, or false, being the number 0. Characters, which you define with char, and my grade in this situation, whoops, forgot to put the equal sign here, are going to be able to store 256 single characters, which are represented by the keys on your keyboard, and can be created as you see. Now, there are many different integer types with multiple different min and max values. And I'm going to list all of them right here. So we have unsigned short ints. You can see here's a min and maximum value. Let's run this. There you go. So you have unsigned short ints. You can see a minimum value is 0. The maximum value is the number you see there. We also have regular integers with a minimum and max. Then we have short ints, and you can see here a minimum and max. We have regular integers, and you can see here a minimum and max value, and we have longs, and you can see how large those are. And you would define them just as you see here. So if I would want to create a short int, I would define it exactly like this, and I could do something like small number is equal to 10, whatever. And you're going to see many examples of those as we continue. Likewise, we have floating point values, and these are going to be values that have decimal places. And if I run that, you can see these values. Here's the minimum and max for floats, as well as doubles, as well for long doubles. And you can see here exactly how I was able to get those. All that you would need to do is type in numeric limits, and then inside of brackets, whatever data type specifically you want to work with, and the minimum or max if you want to get the max value. That's how I was able to display those for you. One thing that is very important to understand, however, is that different floating point data types are only accurate to a certain number of digits, even though they say they can hold extremely large values. So for example, if I would create float f1 equal to, and I'm going to put in 7 ones inside of here, and you're going to see that floats are only accurate up to 6 digits. I'm going to do the same thing. I'm going to create another floating point type. And then I'm going to introduce you to a new function, which is called printf, which allows for the formatting of our output. So I'm going to say here, sum is equal to, and then I want to list a floating point value with 7 decimal places of precision, and then put an F in there for float. And then I can throw in this backslash and N for a new line. And now I can add these two values together, and you can see the loss of precision in the calculation. As you see right here, in the 7th decimal place, we have lost precision. Doubles are going to, however, be accurate up to 15 points of precision. So let's create a double and double. And I'm going to throw 16 ones in there, paste that in there. And we're going to use the same F for doubles, except I'm going to turn this up to 16 digits. And then we can add these together. And you can see we lost precision right here at the 16th point. Now you're also going to be able to allow the compiler to assign the data type by using auto. So I could have something like what am I be equal to true, and it's automatically going to convert it into a Boolean. You're also going to be able to get the number of bytes assigned to a type. So I'm going to say how many bytes are in an integer. And you can see I just keep extending whatever I want the output with these two left-facing brackets. And to do so, I can just type in size of and throw int inside of there. And then follow that up with endl. And you can see there are 4 bytes in an integer. I'll show you some additional ways we can work with printf with different data types. So let's say here that I want to have a character. I would just type in %c, %d for any integers, which are going to be values that don't have decimal places. Let's say that I would want to put in 5 spaces to right justify an integer. I could also put that 5 directly inside of there with a d. Like you saw, I can go and say that I want 3 decimal places to be shown with a double or a float. And then finally a %sign and s for any strings. And then I'll throw in a \n. That's just going to give me a new line. Then directly inside of here, I can just go and throw all of this data. I can also go down to the next line and everything's going to be fine. So I could throw a 10 inside of there, a 5, a 3, 3.1234, and finally high. Always make sure you end with a semicolon. And I got a segmentation fault, and the reason I got that is I tried to put too many values into the printf than what I had assigned. And now it'll run perfectly. And you can see there is the right justification that I added whenever I threw the 5 in there before that integer that I output. Now I'm going to create a string, which is going to allow me to store a series of characters between double quotes. So I can do something like enter a number. I could also come in and create a string without assigning anything to it. So I could say num1 and num2. Then I can output this string right like that. I'm also going to be able to receive user input easily by using cin. And the only thing is I have to change the direction for my stream operator. And I'll say in this situation, I want to store a value inside of num1. Then I'm just going to ask for the other value directly inside of here. So I'll say enter another number. Use cin again to store the value that the user enters inside of num2. If I then want to convert strings into integers so I can actually perform calculations, let's just put an n in front of that, num1. I use stoi and the value that I want to convert from a string into an integer. Then I can come in and change this to 2 and change this to 2 for our other variable. And there are countless numbers of different math calculations we can perform, of course. What I'm going to do here is just add these values together, again using printf, and \ for a new line, and then put those new values inside of there. So on num1, num2, and then I'm going to add those values together, num1 plus num2. Enter a number, I can say 5, and enter another, I can say 4. You can see it performed that calculation. Let's cover a couple of the other basic calculations we can perform. Of course, we can do subtraction. Just change these to subtraction, multiplication, and multiplication, and division, and division. And then finally modulus, which is going to give us the remainder of a division. Run it, and we can go 5 and 4 again. And you can see the output from all of those calculations. You can also see that this one did not work. You can escape out that %sign right there just by putting in double percentages, and you can see over here are the calculations. And that brings us to conditionals. Now, there are conditional operators, which you have seen, greater than, less than, greater than or equal to, less than or equal to, or not equal to, and logical operators. This is and, this is or, and this is not. And basically what they allow us to do is to perform different calculations or execute different code based off of different conditions. And I'll give you an example. So let's create a string, and I'll call this age, and let's just let the user define that. So I'm going to say cout, enter your age. Then I can say cin so that I can go and get that age, age, go and convert this into an integer. equal to STOI and SAge. And now I can use the conditional and logical operators to decide if this user has what I will deem an important birthday in this situation. So what I'm going to say is if the age is greater than or equal to 1 and the age is less than or equal to 18, in that situation, I am going to say that this is an important birthday. So I'll say cout important birthday and endl. Then what I can do is I can say, if I want to check another condition, I can say else if the age is equal to 21, and then here I'll use or and age is equal to 50. Well, then once again, I'm going to say this is an important birthday. And then after that, I can say if the age is greater than or equal to 65, well, in that situation, I'll also say it's important. And if you do not lie within those two areas, sorry, but I'm going to say not an important birthday. And then we can let the user go and define it. So I could say something like 43, not an important birthday. I can run it again, and I could say 4, important birthday, and so forth and so on. So that's how we use the conditional and logical operators, as well as if, else, and else. Now the ternary operator is going to work kind of like a compact if or else if statement. So I'll go and define age 43 is equal to 43. Then I'm going to define a bool, and I'm going to assign it the value that is going to be determined by a condition. So I'm going to say age 43. If it's greater than or equal to 18, question mark. If that condition comes back as true, I'm going to assign to it a value of true. And if it comes back as false, I will assign to it a value of false. However, you could assign integers or floats or anything. It doesn't have to be true or false that's assigned. Another trick is, let's say that you would want to be able to actually print out true or false instead of printing out ones and zeros. You can go cout, setf, ios, and bool alpha, and that will print out trues or falses instead of ones and zeros. So I'll say can Derek vote, and I'll print out the result. I vote. And it says that yes, indeed, I can. All right, so cool stuff. And that brings us to arrays. Now, an array is just a collection of data of the same data type, and you can define them. In this situation, I'm going to have an integer array, and I'm going to go nums, and you put brackets followed with the number of values you want to store. And I'm going to start off by putting a 1 inside of it. It's very important that once the size is defined, that it cannot change. You also would be able to come in here and define the array size depending upon the number of values that you assign to it. So in this situation, I will leave this part, the brackets, blank, and instead just assign some values to it. And the size for that would automatically be 3. And let's go and create another one here and say it's 5 in length. And let's go and just throw 8 and 9 inside of it. Now you're going to be able to access these different array values. Let's say that I want to get the very first value stored inside of the array. Just go and list the array's name. And then if you want the very first one, each of these values inside of the array are going to have index numbers assigned to them. So this one in this situation will be 0. Then the index for this is 1, 2, and so forth and so on. And you can see we were able to get that value out of it. You'd also be able to come in here and change values just by referring to the different index values as well. So let's say I wanted to go and change the very first index to the value of 7. I can do that. And then if we print this out again, you see that it changes. We can also create what are called multi-dimensional arrays. So let's create an integer here, array nums and 4. To do that, you're going to define how many, in this situation, the very first number is going to be how many layers. So you can think of this almost as like a spreadsheet. And then let's say you had different spreadsheet values and rows and columns and such on multiple pieces of paper. This first value is going to be the number of pieces of paper or the number of layers. The very next one is going to be a number of columns on each layer. And then finally, you're going to define how many rows. And we can come in here, and then we will put our values inside of here, inside of curly brackets, and design them up here. And then here, this from here to here is going to define a layer. And then let's go and throw in another layer after that. And then let's change these different values, 6 and 7 and 8. And now if we wanted to come in here and get specific parts of that array, just like we did before, we just go and type in exactly what we want. So in this situation, we're saying we want to get the first layer, we want to get the first column and the first row. Run it, and you can see we're able to get 4, which is this guy right here. Okay, so I'll cover more on arrays as the tutorial continues, but now I want to talk about vectors. Now you're going to use vectors whenever you don't know how big or the size of your array. So we'll go and create a vector just by typing in vector. I'm going to define I want an integer vector, and I'm going to put vnums, and I'm going to say to start off I want it to be 2 in size. We can come in here now and add some values. Again, we're going to use indexes just like we did before. And let's go and throw another one inside of here. Let's change this to the second index, and we'll throw a value of 2. We could also come in here and add another one to the end of this vector just by saying push back, and I'll throw a 3 on the end of that. And we would be able to get our vector size by going vnums and calling size on it, followed with endl. Run it, and you can see there's 3 values inside of it, even though we originally said we only wanted 2. Okay? So once again, more on vectors as the tutorial continues, but before I can really cover them in detail, I have to first cover looping. Now a while loop is going to continue executing as long as a condition is true, and one thing that you'll almost always have to do is to have the variable that's used in your while condition defined before you call for the while loop to execute. So in this situation, I'm going to say that we're going to continue looping as long as I is less than or equal to 20. Again, curly brackets, this is going to be the beginning of your loop and the end of it. And this code will just keep executing forever as long as this condition is true. What I want to do here is if a value is even, I'm going to define that I don't want to print it. How you can check if a value is even or not is you can say I and modulus 2. The remainder of a division is equal to 0. That means it's even. So what happens if I do not want to print it out? Well, first off, I have to consider this condition here. So I'm going to have to increment the value of I. Shortcut way of doing that is going plus equal to 1. That is exactly the same as if I would type in I equals I plus 1, just a shortcut version. And you can do that with any of the basic mathematical operators I showed you before. Well, now that I've incremented the value of I and I want to come up here and continue looping, how I can do that is to type in continue, and it will stop executing any code that comes after this if condition inside the while loop and jump back up here and start executing from this line 1. That's what continue does. Now let's say that I decided for some unknown reason that I want to jump completely out of the loop if the value of I is ever equal to 15. What I can do is say if I is equal to 15, well, in that situation, I want to break out of the entire loop and start executing exactly down here. That's what break does for us. Then I need to come in here and output the value of I, which is going to be an even value. And of course, I have to remember to increment the value of I, otherwise we will get what's called a continuous loop or an infinite loop. Run it, and you can see we printed out all of our odd values up to but not including 15. Now I'm going to show you how to use a while loop with what is called a string stream. First, I'm going to create a vector which is going to hold a bunch of strings, and I'm going to call it words. I'm going to then create the string stream. And what it's going to do is this string stream object is going to receive strings that are separated by a space, and then it's going to spit them out one at a time, and I'm going to stick them inside of the vector. So we'll just have some random words, create another string which is going to hold each of those words as they are spit out. Then what I can do is say while getLine, throw the string stream inside of there, word, which is going to be assigned each of the individual words as they are cycled through. And I'm going to say that I'm looking specifically for a space. And then I can say words and pushback and throw each of those words onto my vector. As the tutorial continues, I'll have tons of examples of things like that. Make sure this is spelled words. Now what I can do is cycle through each index inside of the vector, and I'm going to use a different looping structure this time. I'm going to use a for loop. You need to define your data type. You could also put auto inside of there if you'd like. And I'm going to say that I want to continue cycling through these as long as there are values. So I can use word size inside of there. And I need to increment the value of I each time. Here's another shortcut way to increment the value of I. That just means increment it by 1 plus I. And then let's go and output some values. So I'll say words and I, and there we are. And if we run it, you can see it goes, creates that vector, puts them in there, cycles through, and prints them out on separate lines. Let's go. I'm also going to show you an abbreviated for loop. This time I'm going to create an array. Let's call it array 3. And it's going to have values of 1, 2, and 3 inside of it. You can also go for. Remember I said you could use auto. I'm going to say X. And what I'm cycling through is this array. And all on one line, I can go and say that I want to print out each of the values. Run it, and you can see I printed all those on separate lines as well. And as it continues, I will do even more things with different looping structures and arrays and so forth. And that brings us to do-while loops. So a do-while loop is basically guaranteed to execute at least one time. So what I want to do here is to create a secret number guessing game. And to do so, to generate a random value, I'm basically going to need to seed that, and I need also to include this ctime library to work with time. So I'm going to come in here and I'm going to say that I want a random value, and I'm going to throw time inside of here with null. And now what I'll be able to do is to generate a random value. So let's say I wanted a secret number up to 10, from 0 to 10. So there it is. And I can just call rand now, and then modulus 11. The modulus of a value can never have a value of 11, so the biggest value is going to be 10. I'm going to define guess inside of here. I'm going to have this be set for 0, and then here's the do while loop. So it goes do, and then it's going to execute all of this code before checking for any types of conditions. So I'll say guess the number. Go and get the value that the user typed inside here, stored inside of guess. Then I'll say if guess is greater than our secret number, well then I want to say too big. And then I can go copy this and do the opposite when it's too small. And then I'll just type in too small. And then after it executes once, this is whenever it checks the condition for the very first time. So I'll say secret number not equal to guess. And then we put a semicolon at the end. And then what we can do also is come in and output you guessed it. And end that and run it. So this guy over here is saying guess the number. And I could say 5, too big. I could say 3, too big. I could say 2, too big, 1, and I guessed it. All right, so that's how a do-while loop works, along with a couple other little tricks. And that brings us to strings. Now, a C++ string is, just like I said before, a series of characters that can be changed. So let's go and give it a value. I can say something like, I'm a string. I can go and get the first character inside of it. Let's just go thirst inside there. Just by using indexes like we did with arrays. 0 gets us a first one. Let's go and do a couple different things here. We're also going to be able to get the last one. Type in last just by calling back, which is a function, which we'll get into functions here in a second. We can also get the length or number of characters just by following this with the word length. we're going to be able to copy strings, str2, str1. We could also come in here and say we wanted to copy a string after the first 4 characters by going str2 followed by 4. We would be able to combine strings. str4 is equal to str1 and say something like and you're not. We would be able to append to the end of a string. So you can throw like an exclamation mark inside of there. We can go and run this. You can see got the first, got the last, got the length. We would also be able to erase characters. So let's say we wanted to erase characters from a string starting at the first index. So let's say we wanted to erase different characters from string 4 starting at the 12th index, str4, and then to the end. So I'll say length -1, and let's go and output that. New string, str4, and you can see it went and basically got rid of everything that we added to the end of the string. Find is going to return an index where whatever we're searching for is first found. So how we can use it is we could say something like if str4.find, and let's say what we're looking for the word string inside of this string. We have to say not equal to string end position, and end position is exactly the same as saying end of string. Well, then we could say cout string index str4 find string. Throw this down to the next line and then issue a new line, and you can see it starts at the 6th index. The substring function is going to return a substring starting at an index x with a length of y. So it looks like this, x, y, like that. So what we can do is go cout and substring and str4 substring, start at the 6th index and then 6 characters after that. And you see we grabbed the string right there. We're going to be able to convert, let's say we wanted to convert an integer into a string. So we'll call this string number is equal to, what we're going to do is use a function called toString. And we could even go in here and do something like 1 plus 2, doesn't matter. And then we could say I'm a string, strnum. Let's go and do another thing. Well, let's cover character functions. So let's create a character. We'll call this letter Z and give it a value of Z. Create another character and we'll call this num5. See, I'm putting the quotes around it. Character A space is equal to, and I'm going to throw a space inside of there. What we would be able to do now is go cout and we'll say something like is Z a letter or number? And we're going to check that out. And how we can check that out is with a function called is all num alpha. Let's say is alpha or number. And we'll throw letter Z inside of there. And we can do this with a couple other ones. So that's going to take that character and define if it's a letter or a number. What else can we do? Well, we can just check if it's a letter or not. And that is alpha. We could also come in is 3 a number, and how we check that is with is digit, and well, this would be 5 in this situation, so number 5. And then we could also check if something is a space or not. So we could say is space a space, and just type in is space and then type in a space and run it, and you can see that we were able to get a results that we would be expecting. Alright, so there's how to use a whole bunch of string as well as character functions, and now I want to talk about some math functions. Now there are numerous math functions. You can actually find them all by going to this web address right here. There it is. You can pause your screen, type that in. All the code, of course, is in the description. But here you can see an example of the most common math function you would use: absolute values, mins and maxes, and float mins and maxes, ceilings and floors. And if I run this, you're going to see exactly how they work. So there is all of those different functions run for you. And you can see we have the ability to work with exponents and multiple different types of logs, as well as hypotenuse and all of these trig functions that are extremely useful. And like I said, you can pause your screen to check those out, but they all work pretty logically, so I didn't want to waste any time talking too much about them, even though they are quite useful and important. And now I want to talk about creating your own custom functions. So now we're going to create our own functions. Now C++ is different than some other languages in that we are going to have to define function prototypes. So let's create one. What we're going to do here is we're going to define first the data type that this function is going to return. We're then going to define the name for the function. We're then going to define both the name as well as the data type for the two parameters that can be passed to this function. Then we're going to put a semicolon. Then what we need to do is basically take this, and we basically create this so that main knows what to accept or not what to expect whenever the function is called. Then after main, we're actually going to create our function. And what this function is going to do is, well, we could come in here and define some default values if we would like inside of our function. And that means if a value is not passed, that's what's going to be assigned. And then inside of the function, we can return, we don't have to, but we can return a value. And that value will be a double. Then what we can do inside of main is actually call for that function to work for us. So let's say we want to have a float with 1 decimal place plus, and then another float with 1 decimal place. That's going to be equal to another float with 1 decimal place. Then outside of here, we could then go and put something like 5.0 and 4.0, and then we could call our new function that we just created, which is add numbers. And we just put the function name, and then we pass in whatever values we want to pass in. So 5 and 4, for example. And whenever we run that, you can see we get the output that we would be expecting. Now, one thing that confuses people about functions is how they pass data around between each other. So let's say we want to create a function. It is not going to return anything. That's what void means. However, what we want it to do is to assign a value to a variable called main. It's not going to receive anything. It's just going to do that. So let's come down here and actually create that function. So again, void assign name. It's not going to receive anything, and what it's going to do instead is create a string called name and assign a value to it. And there we go. So now what we should be able to do is come up here and call for assign name, have the variable created in the function for us, and then we can go and print out the name. Seems simple enough, right? Well, let's run it, and you can see that we get an error. It says use of undeclared identifier name, but we declared it inside of the function, you may say. No, you didn't. Any value that is created inside or variable created inside of a function is considered a local variable, meaning that whenever the function ends, so does this variable's value and itself. It ceases to exist. So what can we do then? Well, let's go and let's create another one. Let's call this one assign age and see if we can figure out how to solve this issue. So what's assign age going to do? Well, we're going to pass the variable in this time. And let's go down here and just change this to assign age. And then inside of assign age, we are going to receive an integer, which is going to be the age. And what I want to do here is have it automatically assign age a value of 24. That's a pretty good age to be. So everybody's going to be 24 now. So what we're going to do is come up here. Let's just get rid of this altogether. And let's create an integer. Let's call this age 43 equal to 43. And call assign age. And pass inside of there age 43, our variable. And then after we're done, we will now have everybody be the age of 43, correct? Nope, it shows up at 40 as 43 here. Well, let's just get rid of this altogether here. We don't need it. And you can see that the age still remains 43. Why is that? Well, we are not passing this variable inside of here. What we are instead doing is passing the value. So we get the value, we go and change the value to 24, but once again, that gets lost whenever we leave our function. So how can we solve that? Well, one thing we could do is we could return the value that we want to be reassigned. So how we do that is let's go and create assign age 2 and return an integer. It's still going to get age. Everything else is exactly the same. Assign age 2. It is now going to return an integer. We can go and have the age passed inside of here, and then what we can do is say return age. Up inside of here, we'll have all this be exactly the same, except what we're going to do is say age 43 is now equal to this. So this value right here that is returned is going to be assigned to age 43 right here. And if we run it, now we can see we did what we wanted. But you might say to yourself, well, there has to be a better way. Well, there is actually a better way where we can actually pass the variable's location in memory and access it and change it at will if we would like. But to do so, we need to use pointers. Pointers sound very scary, but they're really not. A pointer just stores an address in memory. So you declare a pointer to be the same type as the data type to which it points. And then you go and access that memory and you can change the value at will. To receive a pointer, you're just going to leave this be int because that's what we're getting, and you put a little star next to it. Then we can come down. Did I change this to assign age 3? Yes, I did. Now we can come down here and go assign age 3. Again, put our star inside of here. We could change this to p age just to point to the fact that this is a pointer. Of course, we're going to have to change this up here as well. So p age. And we're going to be able to change this to void because it's not returning that value anymore. Now we can come down inside of assign age 3. And what we can do is use what is called a dereference operator to change the value at the address. And how you do that is you just type in the star followed with p and age. And let's assign it a value of 22, also a good age. Now we can come back up inside of our main function. And let's go and let's just have this be age 2 just to put something different inside of there. Let's leave the age be exactly the same. We're not going to be returning anything from this. Let's get rid of that. Let's change this to 3, change this to age 2. And if we want to send the address for our place in memory, we have to put a little and sign in front of that, which is called the reference operator. And now what we'll be able to do is actually change the value of the variable itself and have everything automatically work. And I got an error because this needs to be void, of course. And now if I run it, you can see that I was able to change the age to 22. Okay, so that is the way that pointers work, but I'm going to give you some more examples on how pointers work here now. So like I said before, a pointer is just, let's just get rid of all this. So like I said before, a pointer just stores an address in memory. That's all that they do. So what we want to do here is to declare a pointer. So I'm going to say int and star and p age 2. And whenever you are declaring a pointer, it's a good idea to give it a null value. P age 2 can now be assigned using a reference operator, which is this guy, which is going to return the address for a variable. And you store those inside of pointers. Now you can actually come in here and get the address as a hexadecimal number. So if we would like to print that out, we could do so. And to get the address, you just type in p age 2. No stars, no and signs, no nothing. And you're also going to be able to get the value at that address. So we could type in cout, and we could say value. And how you get that is by typing in star p age 2, and then a new line. And I have to throw in a value for age 2. Let's have that be 43. And if we run it, you can see that we have our big giant long address, and we're also able to access the value stored at that address. Now another thing we can do is we can actually create a pointer to an array and then you would be able to cycle through that information within. So let's create an integer array, and let's go and give it the couple values, 1 and 2 and 3 and 4. And let's go and create a pointer to it. So p-int array, just by pointing at that array. And then we would be able to come in here, say we wanted to get our first value. We could just go p-int array like that. And you could see in this situation that we would get that address exactly the same as the address above. And the funny thing is we could actually go and get the second address inside of here just by going, let's go second here, and let's increment p-int array, and we get the next address involved. And then of course you can get the values from that as well, but what I want to do instead is to create a function that is actually going to accept arrays and go and double them. All right, so we're going to just say void. Again, it doesn't return anything. And I'm going to say that I want to double this array, int. It's going to get a pointer to our array, and it's also going to get a size for our array. So let's just go and copy this, come down here. We can go and get rid of this, paste it inside of there. So what this is going to do is use a for loop, start at the 0 index, continue cycling as long as it's less than the size of the array, increment by 1 of course, and then it's going to directly change the values of the array members by multiplying them times 2. It's not going to return anything. Then I'm going to call double array up inside of main, right like that, and inside of it I am going to pass the array that we created, which is int array. And in this situation, this is actually a pointer, so we don't have to do anything fancy. And I know there's 4 values inside of it. And then after that, I can come in and create a for loop again and cycle through those values and print out all of those array values, right like this, and throw in the index. And I got a value that I wasn't quite expecting. Let's go and get rid of that and multiply times 2 and run it. And now you can see we were able to directly go in and double the values inside of those array members. So pretty cool stuff, and we'll be doing more with pointers in the future, but now I want to talk about exception handling. Now exceptions are just errors that occur when things don't go as expected. So what we're going to do here is we're going to trigger a division by 0 error. You can also define all of your variables on multiple or on single lines if you would like. And any code that could be problematic will be stuck in what's called a try block, which there's a try block. So what I'm going to say here is I'm going to say if num4 is equal to 0, then I want to throw an exception, and then I want to handle it. This is the error message, custom error message that I will throw. And then inside of here, I can say else. If it's not 0, well, then I can come in here and just print out exactly what I'm looking for. Divided by, and again, 1 decimal place is equal to, and there is our solution. And then we could say num3, num4, and then have our division be inside of here. Now, anytime you create a try block and you are expecting an exception to maybe be triggered, you're going to have to catch that exception. And we could say catch constant character exception and cout, and then we could go error. And then if we wanted to print out our custom message that we defined right here, we could just type in exp and endl. And if we run it, you're going to see that error prints out on our screen, as well as division by 0 error, which is what we triggered as our error message. All right. So there is a simple explanation of exceptions. We'll be getting more into those later on. And now I want to talk about objects and classes. So what exactly is object-oriented programming? Well, basically what we're trying to do with object-oriented programming is we try to simulate real-world objects or concepts in code. So let's say we wanted to simulate this boy, for example. This boy is going to have attributes such as his height, his weight, his name. In object-oriented programming, these are referred to as fields. This boy also has capabilities, so we will try to model these capabilities also in code. And whenever we do that inside of functions called methods. So what I want to do now is I want to actually come in here and to create a class. And what it is going to do, a class is just the file that is going to list out all of the attributes or fields and the capabilities or methods. So let's come in here and let's just create some classes. So I'm going to come in, I'm going to go new C++ class. And then over inside of here, I'm going to model a generic shape. So I'm going to call this a shape. And it's automatically going to add both a regular CPP file as well as a header file. And I'm going to click finish. And you can see both of those files up here. Now, the very first thing we're going to work with is the header file. And we can get rid of all this. And this code right here, these first two lines, are just going to make sure that we don't accidentally create two header files or include two header files in our programs. And then what we need to do is come in here and just list all the things that make a shape a shape. Now you can see things are separated in public, so these are going to be all of the public functions, and private has nothing. There's also another option we can have in regards to how we classify or protect our data, and that is protected. Now these things all mean different things, and I'll explain them. Now any protected fields or methods are going to be accessible both inside of the entire class, so the class code will obviously be able to work with it, but also if we inherit from this class to create a new one, which we will go and inherit everything in shape in a new class called circle. Well, if it's under protected, that means circle will also have access to all that data. Any public methods or fields that we define inside of here, indented after public, is going to be accessible to anything that has access to our object, and anything that's listed after private is only going to be available in the class code, and subclasses will not be able to access it. In this example, I'm not going to use private. I am, however, going to use protected. And some things that I would like to define for my class would be the shape's height as well as its width. And you can think of this as we saw function prototypes work. Basically, the header is going to define all of the things in our class, and then inside of this file here, we are going to actually define how the functions and so forth are going to work. But we'll get back to that in a second. Now, under public, we're going to define a couple things. Let's say that we would like to have a field inside of here that is going to share values between all of our shapes. We would like to share a value, meaning that every object of type shape ever created is going to be able to access this, and the value will remain the same for every shape. We mark that field as static. And in this situation, it's going to be an integer, which is going to be the number of shape objects that we create. So you can see that it would make sense for this value to be the same for every single object that we ever create. This guy right here is a constructor, and what it is going to do is it's going to be a function that is going to be called every time a new shape object is created. And we're going to have a couple constructors. We're going to define another one that is going to receive a double, and it will have a value of length. We will also have another shape that will receive both a height and a weight, or width, I mean. And you can see, just like function prototypes, we are defining the data types and so forth for the parameters, but we're not doing anything more specific than that. This guy down here is called a deconstructor, and it's going to be called automatically anytime an object is deleted or is no longer used. And the default is perfectly fine to use. However, you may want to make a custom one to release memory or other resources. Another thing I'm going to do is I'm going to create what are called setters and getters. So let's create a set height function, and let's have it be double height is what it's going to receive. And a setter could be used to protect your data. So in a situation where we're defining a setter for height, let's say the user tried to assign the letter A to height. Well, obviously that wouldn't make sense, so we would want to block it. And that's why we would use setters, to protect our data. We're also going to define a getter. So get height is what I'm going to call that. And it is not going to receive anything. It's just going to return the height. And you can see that this is exactly the same data type as what we have up here. And you would use a getter in the situation in which you wanted to store a different value than what you would return whenever they call for that information. And there's other things as well that maybe you would want to store, a change that was made or something like that. Going to do the same thing for width. Now, if you want to be able to access this static value that is up inside of here, you would have to do it using a static method, because static methods can only access static fields. And how you define them is just static, and then we could say something like get num of shapes. And then we're going to create another function, which is going to return a double, and it is going to be called area. And we're going to mark this function as virtual because we plan on overriding it or providing each shape that inherits from the shape class to have a different area function. See, what we're doing here is we're basically creating a generic shape, and then we're going to inherit things like height and width and the getters and the setters and the number of shapes into another class, which is going to be called circle. And circle is going to have a very, very defined version of area where the generic shape would not. And that is all that we need to do for our header file for shape. So we can save that, and then we can jump over here and define everything. Now we're going to include the shape header that has all of our prototype information. And then inside of here, we're going to go and define our functions for real. And this file is called the implementation file. So let's just go and let's copy this, paste it inside of there. And we're going to first go and handle getting past only a single parameter, which, as we saw before, is going to be length. And what's going to happen here is we are going to go and set those values. Now we're going to use a word called this to be able to reference the shape itself, because if you create an object using the blueprint of a class, that could be confusing because you don't know the object's name whenever you create the class before you create the object. So it's one of those chicken or egg type of things. So what I'm going to do is refer to the object's height, and this guy right here is known as the pointer operator, and it's used to access objects, fields, and methods. And I'm going to assign length to both the object's height as well as width. So let's come down here to width, and there we go. And that is what's going to be called if they only pass in a single value into whenever they create a brand new shape. We're also going to handle the situation in which they pass in two values. So let's get rid of length, and instead let's put height inside of there. And let's also put width inside of there. Now we can go and get height, and we can get width. And now we have those constructors created. We can come down to this guy right here and just decide we want to use a default deconstructor. And how you do that is you just go equal and default. And there we are. We're done with that. We can get rid of these two guys as well. And like we said before, we wanted to use setters and headers to be able to protect our data. So let's come in here and define that we want to work with, or define exactly what set height does. And I'm not going to go through the rigmarole of actually protecting the height from being assigned a character or something like that. You could test that out for homework if you'd like. What this is going to do is just simply go in and go this, and height for our object is going to be equal to the height that they choose to assign. We're also going to come in, provide the option to get the height, just like we defined in the header file. You can see I'm putting the class name before all of the methods, and this is going to be get height, and then it's just going to return the value of height, and this has to be lowercase, of course. Okay. Now we have to do the same thing for our width. So set, and then this will be width. This will be changed to width, just like it was set inside of the header file. And width again. Change this to get width, and then this is going to return width. Don't need to do anything else for setters and getters. I have to come in here though and define the get number of shapes, and to access the class's static fields or variables, you're just going to put whatever the class's name is, followed with get number of shapes in this situation. And this guy is just going to return number of shapes. And there we are. And don't forget to close the curly brackets at the end. Now we also had that area function that was marked as virtual. Now what I'm going to demonstrate here is polymorphism, and it sounds really complicated, but it's really not. And any method that is marked as virtual can be used polymorphically. Basically, polymorphism is just a feature in which similar objects can be treated the same. As you're going to see, we're going to create circles, we could create squares, and all types of other different, types of shapes as we'll continue here. And polymorphism just allows us to call a circle a shape or call a rectangle a shape and refer to them as shapes. However, the correct area function is going to be executed because ultimately, yes, they are shapes, but they are really circles. And you'll see that and understand it better through an example. So I'm going to define the generic shape area, and this guy here is just going to return the height multiplied times the width. Another thing I might want to do inside of here is give a default value for number of shapes to be equal to 0. Now I'm going to take all of the information that was defined inside a shape, and I'm automatically going to inherit it, meaning I'll get it all for free whenever I create a circle class. So I'm going to come over here, say that I want a new C++ class, and I'm going to call it circle. Leave everything as default, click on finish, and you can see it automatically created the header file and the CPP file. I'm going to get rid of all that, go into the header file, and if I want to inherit all of the fields and methods defined inside of shape, all I need to do, put a colon right here, and then I'm going to type in public and shape. I could leave all this stuff here, except I want to define that my circle is going to receive a width only, and it's automatically going to use the correct version over inside of shape. So it's going to use this guy right here. Go back into my header file. And the only other thing I'm going to have to do here is define that I want to use area as well. And it's going to return a double. And other than that, don't need to do anything. And once again, these lines are basically just making sure that we do not load more than one header. Now let's go over and define everything. And it's going to be pretty simple. If I want to go and automatically have my deconstructor work, I can just come out of here and say default again. One thing I'm going to have to also include inside of here is our CMath functions. So CMath. So you have to do all of your includes. And then inside of this guy right here, I'm going to say double width is what I want to define with it. And I want to have it handled inside of the constructor inside of shape by passing width to it. Don't need to put anything else inside of there. Everything's going to work. And I can get rid of this if I would like. And then the final thing I want to do is define my area function that is specific to my circles. So I say circle area. And then I define that I want to go 3.14159 and multiply that power, which is going to be width divided by 2 to the power of 2, and that's going to give me my area for my circles. So I don't need to do anything else. You can see how nice and tiny this is, but I got all of this stuff for free that I defined inside of shape. And now I can save it, and now I can play around with these objects over in our main function. So inside of main, if I want to create a shape as well as a circle, well, first off, I'm going to need to include those header files. So I'm going to come in here and I'm going to say include, and then how this differs is you're going to use quotes, shape H, and then you're going to do the same thing for circle. So here's circle, and there you go. Now you have access to go and create those objects. Now down inside of main, I'll be able to create a shape. Let's say I want to call it square because that works out for my generic shapes. There I went, I created it. I could also create a circle. Circle. And in this situation, it just gets one value. Then what I'm going to do is demonstrate polymorphism for you. This function down here is not going to return anything, but it is going to receive anything that is a subclass or inherits from the shape class. So, shape. So it only thinks it's getting shapes, and it's still going to work. And if I would come down here and go cout and area, and then go and get the shape area and print it out on the screen, I can come up here and pass both the square in the circle to our area function, and both of them are going to work, even though I'm calling them shapes. So show area, and I can also pass circle inside of it and save it. And I got a little bit of a bug. Of course, what I need to do here is also include the shape header file. So type in shape inside of here, and let's see if that fixed it. And you can see here it's saying use of undeclared identifier show area. What's that mean? Well, that means that I forgot to go and create a function prototype for shape. Easy enough to do. I just copy this and paste it in, throw a semicolon, save it. And you can see that it was able to calculate the area for my generic square shape, but also it worked for circle, even though that is a circle and not necessarily a shape. So there you go. There's a rundown of numerous different class and object-oriented programming features and options for you. Of course, we will explore more as the tutorial continues, but now I want to talk about abstract classes. Now, the funny thing is because shape has no real purpose aside from just grouping similar objects, it actually should be an abstract class. So let's go and get rid of all this. We can actually go and create the classes directly inside of here. So I'm just going to do that just to keep this simple. What I'm going to do is I'm going to define class shape and public, and then virtual double area equal to 0. That's all I need to do. And then what I'm going to be able to do is come in and say class and circle public shape protected. Of course, I'm cutting out a lot of things here just to do this quickly. Double, going to get a width, and then this is going to be public. Define my constructor. Just have it be like that. Say that width is going to be equal to W. I'm then going to come in here and override the area. So double area and override. And you should use override to force the compiler to check if the base class virtual function is the same as our subclass. And then I can just return exactly what I did before. 3.14159 multiplied times our power function and width divided by 2 to the power of 2. Again, all these other things are exactly the same. And if I would go in here and try to create a square, you're going to see in this situation that it says error variable type shape is an abstract class. So you cannot create objects from abstract classes. So let's get rid of that. And let's get rid of this one as well because it doesn't exist. And let's go and get our show area here, put it up here as a prototype. And make sure that you define show area after you define the shape class. And whenever you do that, you can see that we're still able to get our area. So there you go. There's another quick rundown of abstract classes. And now I want to talk about structs. A struct is going to be used more often to develop a new data type, while classes model more complex real-world objects. But as you're going to see here, our shape definition that we just created with objects is kind of going to work pretty well with structs as well. So let's create a struct called shape. And one thing that's important to understand is that classes have default private fields and methods and such, while structs are public. So what we're going to do is just come in here and define our length and our width. We're also going to have a constructor. So shape. And we're also going to define what's going to go into it and what's not going to go into it. And you can also have default values if you would like. And we can just assign length to L and width to W. We can also put functions inside of here. So let's go and create a area function. And then we would just return our length times our width. Now you can actually have private members inside. So let's go and define this. So let's say we wanted every shape to have an ID. We could do that. So while you can have private data inside of a struct, by default, everything is going to be public. And that's just the difference between classes, which are going to default to private. All right. You're also going to be able to inherit different structs. So let's go and create a circle struct. Going to do it in much the same way as we do with classes. Here we're going to override our constructor, and we'll say double width. We will say this width is equal to the width that's passed inside of it. We can also come in and override our area. We'll define that it returns a double. Its name is area, and it's going to multiply pi times width divided by 2 to the power of 2. And after we have all that defined, we can come down inside of main and make it work. So we can create a shape, pass 10 and 10 inside of it. We could also come in and output this information. So let's say square area, call shape and its area function. Give us a new line, and then we can also do, let's just go and basically just copy this whole thing and then do exactly the same thing with circle. So we'll call circle here, just call it circle. It's only going to receive one value, however, and then change this to circle area, change this to circle area. And another thing you could do is you can initialize a struct or a class using an aggregate. So let's say we want to define this as rectangle, and then let's go and output this, change this to rectangle area, rectangle. And if we run this, you can see that we get the results that we would be expecting. Alrighty. All right, so there's an example of how we can use structs, and now I want to talk about operator overloading. Now you're going to be able to define custom operations just as you define functions, and this is going to allow us to compare, perform calculations, etc. with objects in very custom ways. So what I'm going to do is create another class here, and it's going to model a box. It's going to have some public fields inside of it. So we're going to have double, which is going to be length and width and breadth. We're also going to have a string representation of our box, which we're going to be able to define. We're going to define a constructor inside of here. Let's say they pass in nothing. We could come in and just define some defaults. Let's go and also handle the situation in which they do pass in information, of course. And double for width, and then double for breadth. And let's just go and define all of these also on one line, just to show you that yes, you can do that. And there you go. Now what we're going to do is I'm going to show you how we can increment a box using operator overloading. So you can come in and we're going to say box and operator and plus plus, and this is the increment operator that we have here. And this is what we call a unary operator because it only operates on one object. You would also be able to go and use the decrement operator like that if you'd like. But basically the way it works is you just define inside of here what happens when this functions or whenever this operator is used. So we're just going to increment the value of everything inside of it. And then after we do that, we can return it. And there we go. All right, so before I go and show you how that works in real code, I'm going to go and create some more. Let's say we would like to create a C-string representation, which is actually, as you saw previously, a pointer to an array. So I'm going to say operator, constant, character, and define this. So what we're going to do here is create a stream that can be loaded with characters, and then we will be able to represent it as a string object. So to do that, you go O, stream, string, stream, and I'm going to call this box stream, and then I will go box, stream, and define what the output will be if they try to print out our object. So we could go and output our length and then comma separate everything. And do the same for width, and then finally breadth. And then close that off. And there we can go and generate strings. And then after that, we can return a string representation of the stream and store it in our box string just by going box stream str. And then we can return a pointer to the actual string array. So return box string c underscore str. And that's what that'll do for us. Now there's also going to be binary operators. So like plus and minus and multiplication and divisions, and greater than, less than, equal to, pretty much anything that's going to operate on two objects. I'll give you an example. So let's say we wanted to go and work with the addition of our custom objects, constant. We're going to say box, and this will be called box2. We were going to create a sum of those two values, and then we can say box sum length is going to be equal to length of this object plus the one that was passed inside of it. So box2 length. We can just add them together. And let's go and copy this. Do the same for the other two. So we'll also say width and width and width and breadth and breadth and breadth. And there we go. We got them all in there. Then after we've added those together, we just return the sum. So return box sum. And there we got it. And I'll give you one more. Let's say if we wanted to check for equality for our boxes, we're of course going to return a Boolean. Just define the operator you want to work with, which is the equality one, constant, box, and obviously this is going to be box2. We're comparing this box to. And then all we need to do is just go return and define our conditions for this to be an equal box. So we'll say, is the length equal to the box2 length? And then we'll say, and is the width equal to the box2 width? And then of course we'll say, and is the breadth equal to the box2 breadth? Okay, so there you go. That is how that's going to work. And everything is defined. So now let's go down here and actually play around with it. So down inside of main, we're going to go and create a box. Just call it box. Give it a value of 10 for everything. Let's say we want to increment our box. We can do so. We can then also go and output using our conversion into string, and it's automatically going to work for us. See, went and incremented all those different values. We're also going to be able to create another box and then add these boxes together. Let's go and give it a value of 5 in all parts. We can then come in and output the addition of those two boxes. So we could say box 1 plus box 2 is equal to, and then we can just go box plus box 2, just as simple as that. And you can see we added them together. We're also going to be able to check for equality between our boxes. So let's just go and copy this, and we could say box 1 is equal to box 2. And to check for that equality, just go like this, throw the equal sign inside of there, run it, and you can see that no, they are not equal. All right, so there's a whole bunch of examples of operator overloading. And now I'd like to talk about lambda expressions. Now we actually created this function earlier. This is going to generate a random vector of integers. Generate random vect. You pass in the number of numbers that you want to receive. And then you also pass in the minimum value as well as the maximum value, like that. And since we did this already, I'm just going to briefly go through exactly what goes in. Of course, number of numbers, minimum and maximum. We create a vector to hold all those. We're going to use the time function to generate a seed so we can get random values, or we are going to come in and then generate the random values by adding the minimum to whatever the random is, the maximum plus 1 minus the minimum, and then we're going to push all those random values onto our vector. All right, so just want to briefly cover what I previously covered before I get into lambda expressions, which is what we're here for. Now, lambda expressions are going to make it very easy to perform list operations all on one line of code. So let's say we wanted to go and generate a vector. We could do that here using our function. So we could say vector, this is an integer vector. We're going to call it vec_vals. And then we just call our function generate random vec. So then we want 10 values starting with a minimum value of 1 and a maximum value of 50. So there that is. And let's say we want to sort all these values. We could say sort vec_vals and start at the beginning through the end. Change this to uppercase. Then we're going to go and use square brackets, which is going to designate that this is a lambda expression. And then we can go and get each of those values inside of the vector. Change this to vect. And then it will return the value if x is less than y. Close that off. There we go. Now what we'll be able to do is come through and print all these out. Cout and value. Throw a new line inside of there. And I forgot to throw a semicolon there at the end. And throw a t down inside of there. And if I run it, you can see that it generated a random vector and then sorted all those values. And we can run it again, and we can run it again just to show you that they're all random. Okay? So there's a way of going and sorting the vectors. You're also going to be able to come in and use something similar to filter in other languages, except this is called copy_if. So let me show you an example here. So we could say copy_if. And what we want to do here is generate a vector of even values, or keep only the even values from our random vector that we generated. So first off, I'm going to go vector. Let's go and get rid of the sort here first. So I'll go vector, again, integers, and this is going to be the even vector values. And then we'll say copy_if. Again, we're going to start at the beginning of the vector through the end. So beginning vec values, and then vec_vals, end. Then we'll go back, inserter, even, vec_vals, to throw all those values inside of there. And then we'll define our lambda expression. What it's going to do is cycle through each of the values in the vector one by one, and return them and store them inside of even vector values if that value, modulus 2, is going to be equal to 0. So we're going to store it only if it meets that condition, just like we did previously. And then we can cycle through these again. We could say auto, value, even, vec_vals, and then output each of those values. And you can see it went and outputted just the even values. Okay, so pretty cool stuff. Let's say you'd also like to come in here and sum a list. Let's go and get rid of this. For each is going to cycle through all of our values. So we'll use vec_vals again, and then guess what? We're going to start from the beginning of the vector to the end, just like we did before. And then the and that we're going to put here between square brackets is going to designate that we want to capture all variables used in the body of the lambda that we're referencing. Again, we just temporarily store each of the vector values in x, and then we sum all of these values. And we're going to have to create an integer called sum, which has a value of 0 here first. And then we can output that information as well, right like that. And if we run it, you can see there's the value. And of course, because the vector is random, the sum will be random. Okay, so there is a quick rundown of some lambda examples or lambda expression examples. And up next, I'm going to talk to you about file I/O. Now for this example, make sure you include all the libraries that I have here. And what I'm going to do is I'm going to come in and I'm going to first off define a stream that is going to be used to write to my file. So let's call this write to file. I'm also going to define another stream that's going to be used to read from our file. Going to create a string, which is going to be the actual text that I'm going to write to the file. Start off with an empty string. And then another string, which is going to hold the text that we get back from the file. So let's call this from file. also empty. Now the very first thing we got to do if we want to write to our file is we're going to say write to file, and then we'll call open, and this is going to open the file. And what you need to do is provide a name for the file, and if it doesn't exist, it will be created. And I'll go iOS base and out, and what you're going to put here is you would put app right here where out is if you would want to append to the end of the file. If you would put trunc like that. If the file already exists, it's going to first delete the content before adding additional. You could use in if you wanted to open the file for reading. You could type in 8, which is going to open the file and then move to the end of the file to start adding additional information. Or out, like we're going to use, which is going to open up our file for writing. But you can actually combine these, which I'm going to do right here, and go iOS base and trunc, which is going to do what? Remember I said it's going to, if the file already exists, it's going to delete the content before adding additional content to it. Okay? So then we're going to come in and we're going to say if write to file is open. So can we write to our file or not? And if we can just say write to file. And what we want to write is just beginning of file, and then throw a new line inside of there. Let's close off this if statement. You can also write data in a string by going cout, enter data to write, and let's use getLine this time, and this will be the additional text that we want to write, and then write to file, and that text that the user enters we will automatically write to our file. And then of course after we're done with that, we want to close our file. All right, so there's all that. And then we're also going to throw in the fstream library for working with our files and run it. It's going to say enter some data to write. I'm going to say is an important string. Enter. And there we go. Now we have to go and verify that that information was written. How are we going to do that? Well, we're going to come down inside of here. Actually, let's block out this code because we have already written to our file. I'm going to say read from file open. Again, the file that we want to work with, iOS base, and in this situation, I want to read from it, so I'm going to put in inside of there. And then I need to verify that the file is open for us to read from it by calling for is open. And then I can read each of the individual lines, and how I do that is call read from file with a while loop, calling good each time through our while loop. And then I can say getLine, read from file, and then text from the file where I want to store that information as I read it through. And then I can go cout text from file, and then after we're done with that, I can go and close the file right like this and run it, and you can see that it went to our file and output all the information from it. All right, so there is how we can input information into files as well as read data from files. And now I want to talk about how we can use functions as objects. All right, so let's come in here and let's define some functions. So I'm going to say that I want to create a function that is going to multiply values by 2. Say double num, and what it's just going to do is return whatever is passed into it times 2. Now what I'm going to be able to do with this is actually store this function as a variable. So I can go auto and call this times 2 and assign that to our newly created function, and then go and output that information just by referring to that variable times 2. And I can throw 5 inside of there, and there you can see it worked exactly as we would have thought. What's really cool is I can actually pass a function into a function. So up inside of here, I'm going to create another function, and I'm going to call it doMath, and it's going to receive a function. And what I have to define here is the first double is going to represent the return type, and then that's going to be followed up inside of here with the data types for any parameters. And in this situation, there's only going to be one. And I'm going to call this function just func. And this is also going to receive another number value. And then what it's going to do is return this new function using the number that was also passed inside of it. So what we can do here is jump down inside of main and go cout, and 6 times 2 is equal to, and call do math, throw in our times 2 function and the value of 6, and it's going to perform another calculation, as you see right there. So kind of neat stuff. Another thing you can do is you can store your functions inside of a vector. So let's go create another function. So we'll say double, and we'll call this mult by 3, and it's going to receive a double, and guess what it's going to do? It's going to return that number times 3. Well, we can come down inside of here and define a vector, which is going to have functions inside of it. Again, the first double is the return type, and after that we will follow all the parameter data types, close off our vector, and we can call this funcs, and there's 2 of them. And then we can say funcs and assign mult by 2, and in the next space in our vector we can go and assign mult by 3, and then we can come in and perform that calculation, and I'm going to say funcs and pass 10 inside of it, and you can see that worked as well. Alright, so pretty cool stuff. And now I want to talk about macros. Now there's 2 types of macros. We can define a macro constant, and in this situation, anywhere you see the uppercase P and I, it's automatically going to be replaced with whatever value you put inside of it. Also, we have macro functions. So we can define, for example, area of a circle, and anywhere you find this, we'll take the radius, which is passed inside of it. Then we can use pi, which we just defined, and multiply that times the power of radius, taken to the power of 2. And then we can jump down in main to test this out. So we could say circle area, call our macro, pass 5 to it, and there you go. Alright, so quick example of how to use macro constants and macro functions. Now I want to talk about template functions. Now we're going to be able to use templates to create functions or classes that can work with many different types. Now templates are going to differ from function overloading in that instead of having a function that does similar things with different objects, a template does the same thing with different objects. So we're going to come in here and we will define template, and we're going to say type name t, and then we'll say void times 2 t value. And this is basically saying that this is a function template that generates functions that accept 1 parameter. And what we're going to do here is say cout value times 2 is going to be equal to value times 2. So now we can jump down inside of main and go times 2 and pass in 5. But we could also come in and go times 2 and pass in 5.3, for example. And if we run it, you're going to see it works with both integers as well as floats. And we're also going to be able to work with multiple parameters. So we'll go template, type name, t, just get rid of this. And I'm going to go t, add t val, and t val 2. Now both of these are going to have the same data type, but what this is going to return is those values added together, obviously. And then we can come in and do something like 5 plus 4 is equal to, and then call add and pass in 5 and 4. Also, we could come in and do something like 5.5 and 4.5 and work with ints and floats. And you can see those both work as well. Let's go and create another one. This time what I want to do is get the maximum value. So I'm going to go max, and this is going to work with characters and strings. So what I'll do here is I'm going to say val less than val2 question mark, and it will return the maximum value. depending upon that condition. So we can say max of 4 or 8. So we'll work with numbers, but we'll also be able to work with characters and strings. And just pass in the 4 and the 8, but then do either other ones. And we can try A or B, A or B. Or we could come in and do the same with dog or cat. And it's automatically going to work for us. Dog, cat. Run it, and you can see it works. All right, so cool stuff. We can also work with template classes. Here I'm going to define a template class, which is going to be a person. And template classes are going to be classes that can work with multiple different data types, of course. So I'm going to say template, type name T, and type name U. And you can define that you may receive parameters with different types, but they don't have to be different. So you have options here. We can say person, public, and I'm going to go T, height, U, weight, define a static, which will be num of people, person, and then you can see how these match up. We can go and assign the value of height and the value of weight, increment our number of people, and then come inside of here and say we want to get data on this person type, and it's going to just go cout height, output our height, and then we'll say and weight, output our weight. And then we can come down inside of here, inside of main, test this out. So we'll say we want a person, and whenever you're creating the object, you must define the data types that are going to be used. So we're going to say that we're going to work with doubles, get that question mark out of there, and an integer, and this is going to be Mike Tyson. We're going to pass in 5.83 and 216, and we can go and get some data on this. And you're also going to be able to access your static values using the object. So let's go number of people, Mike Tyson, num of people. Don't forget, however, to initialize your static class members. Template, type name, T, type name, U, int, person, T, U, and then we'll go num of people, like that. And if we run it, you can see that that all works out. And also you could go in there and change these to ints and doubles, and they will also work out, flip them and flop them and do whatever you'd like. All right, so there is another example of how to go and define a template class. And now I'd like to talk about containers. Now we have already seen the container vector and how useful it is, but there are many other different types of containers. First one we're going to talk about is the double-ended queue, and how you define it is by typing in DEQUE, and it's going to contain integers. And what makes it different is it's a dynamic array that can be expanded or contracted on both ends. So let's go and give it some values. And then let's go and push a value onto the front of it with push front. And then likewise, we can go and throw a value onto the end of it with push back. We've seen that before. Let's throw a 5 on there. And we're going to be able to cycle through these values just like we did with our others. Go and output those on separate lines. We're going to have to add a couple more libraries though. So let's come in here and we'll say include DEQUE. And also I want to talk about iterators. So let's go and include those as well. Iterator. And then come down here, run it, and you can see there is our output we were expecting. You're also going to be able to access index values, but this is a costly operation because values aren't stored contiguously, but things with different objects. And in a situation in which you would want to normally do this, it's better to use multiple arrays. But you can come in here and go cout nums and L and find those individual index values. And I think that's a good just example of how to use double-ended queues. And now I want to talk about iterators. Now, iterators are going to be used to point at container memory locations. So let's go and create a vector here. just going to be an integer vector. And let's call this nums2 and go and fill it up with the same types of values. Now what we want to do is to define an iterator as the same type, and we'll mark it as iterator. And I'm just going to call this itr. And then let's cycle through it. To do so, we can go for iterator equal to, and we're going to use begin and end as well, just like we did previously in examples. And then while the iterator is less than the ending. And then we can increment this, and then we can output it. How we do that, star iterator endl, run it. You can see there we get our output. But you're also going to be able to increment a set number of spaces. And to do this, we're going to create an iterator and point it at the beginning of our vector, just like we did before. So iterator, let's call this itr2 equal to nums2 begin. And now let's say that we would want to advance 2 spaces. Well, we can call advance, call our iterator, and 2 spaces. And now, if we go and output this, you can see that's exactly what it did. Next is basically going to work like advance, but it's actually going to return an iterator. So let's go auto iterator3 is equal to next, refer to iterator2, and then we can go cout iterator3, and you can see how we advance to 4. And if there's a next, well, there's probably a previous, and in this situation there is. Let's create another iterator. Let's call this iterator 4, get the previous location, and then let's output this again, but just have this be iterator 4 instead. And you can see it jump back to 2. We're also going to be able to define an index where we want to insert. So I'm going to say vector int, and let's call this nums3 equal to 1, 4, 5, and 6. Create another vector, also an integer. Let's call this nums4, and let's go and get the 2 values that are missing here. Throw those there. You can then go iterator 5 equal to nums3, get the beginning location of it, and we can advance using our iterator by 1 position. And then we can go copy from the beginning of nums4 and nums4 end, and then use inserter to put nums3 where we iterated to. And then we can go and output this just by going int and I, and do this on nums3, and just output each of those individual pieces to see that we added in those values. And there you can see we did. All right, so neat stuff. And that's some good information on iterators and double-ended queues. And now I'd like to talk about smart pointers and malloc. All right, so we need a couple more libraries inside of here. I'm going to go and include memory and spell include correctly, and also include standard IO library, because we're going to be doing some C type of stuff here. Now, whenever we define a primitive type like an integer or a float, you define exactly the amount of space that you want to set aside. So we all know that. If, however, you need to define how much space to set aside, you could use a function called malloc, which is going to tell it how much space to set aside and then return the address to that memory address. So let's go and get the amount of space that we want to store. So we could go and say something like, how many numbers do you want to store? That's going to output onto our screen. And then we can go and get that information from our user, amount to store. Then what we're going to do is we're going to create an integer pointer to set aside enough space. So we'll go int pnums. Then we're going to go pnums and cast the pointer and define how much space to set aside. So int memory allocation amount to store times the size of a standard integer, like that. Then we can also come in and check if that memory was actually allocated for us, just by checking to see if null is there. define int I, and then what we can do is go and store those values. So we'll say while I is less than the amount to store, and we can ask them to enter a number. Enter a number, and then store that number inside of here by referencing pnums, and then increment the value of I. Then after we do this, we can come down and we can output you entered these numbers, and then cycle through them. So we'll say int I is equal to 0, while I is less than the amount to store, and then go and output each one of those values just by using pnums and cycling through them. After we're finished with it, we can delete the pointer, and if we run this, whoops, forgot to go up here and actually assign this, so throw an equals in there. You say how many numbers do you want to store, and I could say something like 4, enter a number, 1, 2, 3, 4, and you can see it outputted those values that I entered inside of it. So kind of neat stuff. But we could also use something called a smart pointer to do much the same. So again, we're going to say the amount to store, how many do you want to store, and then go and get rid of everything else that's there. And then what we're going to do instead is go unique pointer integer array, and this memory is going to be automatically reallocated for us. So we can just go pnums new integer and the amount to store, and then just say if pnums is not equal to null, int I is equal to 0, and we can go and store these values. Go I amount to store, and go and ask the user to enter a value just like we did before. Go and store that value and increment I, of course. Then after we're done with that, we can go and output those values. You entered these numbers like that, and then cycle through them with our for loop. I less than the amount to store, increment the value of I, and output them on the screen like that. How many numbers do you want to store? We can say 3, 1, 2, 3, and you can see there we got the exact same results in a much easier way. All right, so now what I'd like to talk about is how we can work with threads. All right, so threads are just going to be blocks of code that we are going to be able to execute at the same time, which each individual block of code being executed, in this example, whenever one of the other threads of executable code goes to sleep. So we need a couple more libraries. So I'm going to come in, include thread, of course. Then we're going to get some different time libraries that are going to allow us to output some more information about time. I have ctime inside of here, right? Yes, I do. And mutex. All right, so we got those in there. What I want to do here is create a function that's going to generate a random integer. So I'll just call this get random, and it's going to get a maximum value, and it's going to go and generate a random value. So again, we're using time to generate the seed that is going to be used to generate this random value, and it's going to then go rand and use modulus with max to make sure we don't go over the maximum value that we're looking for. Go and create another function, and it's going to be called execute thread, and it's going to get an ID assigned to it so that we can track it. We then want to get our current time. Now time is equal to chrono, and we go system clock and now, which is going to be when I execute this code. What I want to do now is convert the time so that we can output it. So I'm going to go time t sleep time is equal to chrono system clock to time t now time. I'm going to, if you wanted to convert it to the current time zone, I'm going to call this my local time. You do that by saying local time and sleep time. This is just going to track whenever the threads are executing and whenever they are being paused or they are in a period of sleep. Now what we can do is go and print out our time information as well as the ID for our thread we're working with. So I'm going to say thread and the ID that is assigned to it. And I will output our sleep time. And I'll go C time, sleep time. And then I can also, just to show you some more information in regards to what you can do with times, I can get all these individual parts and individual pieces. So I could go and get our month by going my local time and then TM-MON. So that's going to give us our month. And let's go and do this for a couple other different things so you can see it. And we can also get our day by changing this to M-day. We'll also be able to get our year, trying to cover as much information as humanly possible. So let's go and change this to year. And you have to increment that to by 1900. Let's also go and get hours. Change this to hour. And then let's also get minutes. Change this to min. And seconds. And I think that's enough. Seconds. And then change this to SEC. Alright, so actually after we output all that information, what we're going to do here is put the thread to sleep for up to 3 seconds. So I'm going to go this thread, sleep, for chrono, seconds, and I'm actually going to get a random value with a maximum of 3 by using our random function we created earlier on in this. Now I can go and get now time, chrono again, and system clock, and that's going to be the now time, current, time. Go and get sleep time. Again, this is going to be chrono and system clock to time. Whoops, to time. T, pass in now time. And then let's output all of our information. So we can say out or cout and thread, and let's go and output that ID. And this would be the awake time. And to get that, we go C time and sleep time, like this. And then it's a big complicated function. It's going to print out a lot of time information. Now down inside of main, let's go and actually get this to work. So what I want to do is create a thread. So to do so, you go thread, and I'm going to call this thread 1. And I'm going to pass in the function that it is going to execute, as well as the ID associated with it, which is going to pass to the function execute thread. Then I will call join on it. And what this is going to do is join the thread to the main thread, meaning that the main function, this guy right here, this is also a thread, is going to wait for this thread to stop executing before it continues executing, itself. I can go and create another thread then. Let's call it thread 2. And again, it's going to do exactly the same thing. Go up and execute that function. And again, it's going to join. It's going to ask for its time to do its work. And we can save it, run it. Got a little error here. That's system. Let's verify. I don't have any other errors here. I don't believe I do. Nope, everything else looks good. And then we can execute these threads. And you can see here how the threads started up. There's all that time information that we had here, how it woke up, and this is thread 1 obviously, and then all the information from thread 2. So neat stuff, and that was just a quick example of some different things we can do with time as well as threads. And I have a huge C++ tutorial that provides a whole bunch of other examples working with threads. But now I want to talk more about some sequence containers. All right, so now I'm going to cover a whole bunch of additional containers that we have available to us. I'm going to cover decks. I'm also going to cover lists and also forward lists. Okay, so let's jump into these. A deck is basically just a dynamic array like a vector, except it's going to allow us to insert or delete from our front. So to create one, we're going to go deck int, and let's just call this deck1. Then we can go deck1 push back 5, and then we can also use push front, and let's throw 1 inside of there. We're also going to be able to add multiple different values. So once again, deck1, and we'll do this with a sign like that. We're going to be able to get the size by going deck1 and followed with size. But if we would go and throw the size in right here, and we throw the size in after, you can see that we still have a value of 2. Why is that? Well, let's go and print out all of the values inside of it. And you're going to see that 11 and 12 are inside of there, but not 5 and 1. And that's because assign went and replaced those values. Okay, let's go and do some more. We're going to be able to access these values by index. So dec1, and we can just say we want the first one. We're also going to be able to come in and get at a specific index with @ So we can just get rid of this and type in .at and throw the second index in that situation. We can add at a specific index. So we're going to use an iterator for this. So go and define an iterator, call it it, and go and assign it to the beginning of our dec, and then increment that by 1. Then we could go dec1 and insert, use our iterator, and a value of 3. And you see we were able to put the 3 inside of there. We can also add in multiple values. So I'm going to say int, and I'm going to go and create a temporary array that's going to have 5 values inside of it. And there's our values we want to add into it. And then we can go dec1, insert, and dec1, and let's go to the end of it. Point at our temporary array, and then go temp array plus 5. Run it again. You saw we are able to add those values inside of there. We'd also be able to erase at a specific index. So we could say dec1 erase, and let's say we wanted to erase the very last element inside of it. There you go, got rid of it. You can also erase multiple different elements. So we're going to use erase again here. So let's just throw erase inside of there. But this time what we're going to do is we're going to say that we want to start at the beginning, and then we want to erase the first 2. So let's just go and get the beginning, paste that inside of there, and then follow that up with +2. And that's going to reach that index. We would be able to pop off our first value with just pop front. We would also be able to pop the last value off of it with pop back. We could go and create a brand new dec. This is going to be integers, and we'll call this dec2. And let's say that when we want to have 2 values stored inside of it, both of which are going to be 50. There you go. We could also swap values in decs. So we could say dec1 and swap with dec2. Run it. You could see that those were all swapped. And then we could also delete all the values. Okay, so there's a good rundown of how we can use decs. And now I want to talk about lists. Now, lists are going to be very efficient at inserting, moving, and extracting elements, but they are going to lack the direct access to those elements. So I'm going to create an array, and I'm going to give it some values. Create a list. This is going to hold integers. I'm going to call it list1. And I can go and insert the values inside of the array in the list by going list1, insert. I'm going to say that I want to start at the beginning of the list, and then I'm going to put in the first index from the array, which I can just reference the array and it'll work, and then increment that by 5. And then I can change this into list1, and you can see I have all those values inside of there. Again, we would be able to add values using assign. So we could put 10, 11, and 12. And you can see there, they replaced the original values that were inside of there. We could add to the front and the back. So push back, throw a 5 there. We'd also be able to push onto the front just by changing this to front, changing this to 1. You can see if we run it, those values were added. We'd also be able to get the size as well. So cout, and we would just type in list1 and size. There's our size. We cannot, however, access the index, so I'll show you that. So let's say I want to get the very first index, and we can try it, but no, we're going to get an error because we're not allowed to do that with lists. You can, however, access the index with an iterator. So let's go. List, integer, of course, iterator, call this it2 equal to, and you go list1 starting at the beginning. And then we could say something like advance the iterator by 1. And now, if we wanted to come in there and get it, meaning the second index value. We just go IT2, and now we're able to get that value. Well, actually, in this situation, it would be this guy right here is the one where we got the value. That's why it's helpful to do things like second index. And now you can see there it is. All right, so what else can we do? We can insert at a specific index. So I'm going to go IT2 is equal to list1 and the beginning of our list. See how useful iterators are. And then go list1, insert, pass in IT2. Let's say we want to throw 8 inside of there. Run it. Now you can see the 8's there. We can erase at an index. We can go list1 again and erase. List1, and let's say we want to get out the beginning value. Could do it. We could also go in and erase the first 2 values. Iterator again. Let's assign it to the first one. And then list int. Create another iterator. IT3. And let's go list1 begin again. We can then advance that, being that next iterator, by 2, and then erase some values. So we can go list1 and erase, and then pass in the 2 iterators. Run it, you can see we're deleting those values. And then also we could come in and pop some values off. So let's pop off the first value, and then we can also pop off the last value with pop back. Let's go and create ourselves another list after this. Int array2, and let's set aside 6 values. 10, 9, 8, 7, and we'll throw 2 6s inside of there for a reason you will see very soon. So then let's create our list, integer, and let's call this list2. We can go and insert that array inside of there by saying we want to start at the beginning of our second list that we're working with here. Whoops, this will be list2. And then reference the first index of our array and through the 5th index in our array. Let's change this to list2 if we'd like. Whoops, somehow got a quote inside of there and another quote there. All right, let's get rid of that and run it. You can see those are all set up. We could come in and sort our list just by saying list2 and calling the sort function. We'd also be able to come in and reverse it by calling reverse on it. We'd be able to remove our duplicates by calling unique. We can remove an individual value altogether by calling remove. And let's get rid of 6. We could also come in and remove if a condition is true with remove if. And we could have this call a function or do something completely crazy. Like, for example, a function that would check if a value is even, for example, and it would remove those values if that came out as true. We'd be able to merge lists as well. So we can go list1, merge with list2. And I think that's just about it. Let's run it. And you can see here that list is kind of chopped up. Now let's go and try list1 instead. And you can see all the values. All right, so rundown of a lot of different things we can do with lists, and now I want to talk about forward lists. Now a forward list, and you can see the library for it up here, is basically like a list, but each item only has a link to the next item in the list. And it has no way of getting to any item that precedes it. And by organizing the list in this way, it makes them very quick sequence containers. So what we're going to do is we're going to create forward list. It's going to contain integers. Let's call this FL1. And let's assign some values to it with assign. Just 1, 2, and 3, and 4. Now we're going to be able to push a value onto the front. And likewise, we'll be able to pop values off of the front. Get rid of that index right there. We're going to be able to get the first value off of it. So let's just call this front by going FL1 and then calling front on it like that. We can run it. There you go. We're going to be able to get an iterator to get elements as well. So we'll say forward list, and these are integers, of course. Iterator IT4, and let's just point at the front of it. We can then insert after this first element with this iterator. So go IT4 equal to FL1, insert after IT4, value of 5. Let's go and output this information. And there you can see how we were able to output them with a simple for loop. We can go and place different values in our first position, FL1. To do that, we'll go in place, front, throw a 6 there. Now you can see it. We can remove values with remove. So let's look for 6, remove it. It's gone. We could also use remove if, like we used before, what I talked about before, where we could call a function. And if a condition comes back as true, we could remove a value. Let's go create another forward list. Again, integer. Call this FL2. We could go and assign values to it. So 8, 7, and then throw 2 6s inside of there. We could remove any duplication by saying that we want all the values to be unique. And of course, like we did before, we can call sort. We can call reverse. We can go and merge the first one with the second one. And we could also come in here and completely clear all the values out of that and throw this here and da-da-da-da. And you can see there's only that, and that's because we cleared this out. Let's get rid of that, take this, throw that there, da-da-da-da-da. And you can see there is our final list. All right, so a whole bunch of things we did there. And now I want to talk about some of the associative containers available to us. Now, an associative container is going to store sorted data, which is going to make insertion slower, but searching much faster. First one we're going to cover is the set, and how we create one of those is go set int. And basically a set is going to store unique sorted values using a key. So let's just call this set1, 5 and 4 and 3 and 2 and 2 1s inside of there. We can go and get the size of this guy just by going set1 and size like we have previously. Let's go and for int I and set1. And also make sure you include the set library. And you can see if we go and output all those values that they show up right here. Let's go over a couple more functions. We're going to be able to insert values, set1 and insert. And let's just say 0. You're not going to be able to access them like set1 and 0 like this, but you can use an iterator. So let's say we want to get values with an iterator. We just go set int iterator it is equal to set1, start at the beginning, increment our iterator, and then we can go and get our second value by referencing the iterator, changed position, and you can get the second value like that. You can also erase a value, set1 and call erase on 5. You could erase the last 2 values. So again, IT in this situation, we'll go set1 and reference the end, and we can go advance. And we can actually move iterators backwards also by using -2. Don't know if I covered that before. And then we can go set erase iterator to the end. And you can see we erased those values. We're going to be able to add multiple different values. Let's go and create another array. And let's throw 6, 7, 8, and 9 inside of there. Set1 and insert, starting at the beginning of the array, 4 items in, where you'd be able to find a value by going set1 and find and 6. And this is going to get the iterator and then our value. So we can go found, for example, iterator reference, and you can see it found 6. We can also get an iterator to a value. Going to use auto again. We'll just call this 8. Set1, lower bound 8, and then go and get that. There you go, found it again. And what else can we do? We can get a iterator to a value after. So let's say, let's just call this 9 equal to set1, upper bound 8, and then 9 and 9 And there we go. And let's do a couple more here just to say I covered just about everything imaginable. Let's go and say we wanted to swap values in sets. Let's go and create set 2. Throw 10 and 11 inside of there. And then we can go set 1 and swap with set 2. Da-da-da. And there we go. So there's all kinds of crazy things that we can do with sets. And now I want to talk about multi-sets. Basically, a multi-set is just going to store duplicate values in a sorted order. And other than that, they're basically exactly the same as a set. So let me just give you a really brief example here. Let's go create a multi-set. Now, a multi-set is going to be very similar to a regular set, other than duplicate values are going to be sorted in order. And I'll just give you an example. So I'm going to say multi-set int mset1. There we go. I can insert values. So there's 4 and insert 0. I could check if it's empty or not. So I could say if the multi-set is not empty. Well, in that situation, I'm going to go and output these values like that and run it. And you can see that they all printed out. All right, so cool beans. And now I want to talk about maps. Now, a map is going to store using key-valued pairs. And one thing that's important to know is that you cannot have duplicate keys. You can't have duplicate values, however. So I'm going to define, it's going to have an integer, and it's going to have a string. And I'm going to say that the name of this is map1. Now what I'm going to do is go map1 and insert some information. I'm going to say pair. This is going to be an int and a string. And what I want to insert is 1 and Bart. And this is the key and this is the value. Let's go and throw some more inside of here. Could also throw 2 and Lisa and 3 and Marge and 4 and Chuck. All right. So we can find the element by a key. So we can go match equal to map1 find 1 and then go match and second. And don't forget to include our map library and run it. And you can see it went and grabbed Bart out of there because Bart has the key of 1. You can go and get an iterator to a value. So this is going to be Bart equal to map1 lower bound and throw 1 inside of there. And then go Bart and second. You can see there's Bart. We could also get the next iterator. Let's call this Lisa. Map1 and lower bound again. Except in this situation, we'll throw 1 in there again. And then we'll say upper bound 1. And then go Lisa. Second. Boom, there's Lisa. And we also will be able to get keys and values using the iterator. So we could say map, again, int and string, iterator. And I'm going to call this it2. And then we can say for it2 equal to map1, start at the very beginning of it, it2 not equal to, so as long as we don't go to the end, then I'm going to increment my iterator. And now what I can do is go and get the keys and the values. Keys, and how you get the key is go to the iterator 2 and say first, and then we're going to do the same for our value by saying second. Don't know why those aren't called keys and values, just the way it is. And second, and there we go. We got all of them. All right, so there are maps, and now I want to talk about container adapters. Now there are multiple different types of containers that are set up to provide a defined type of interface. So you can have things like last in, first out, so forth and so on. Well, if you want a last in, first out container, the way you would do it is with a stack. So you have stacks. This is going to contain strings. I'm going to call it customers. And if we want to go and push on some customers, we do it with push. And we'll go George, for example. And we'll throw on a couple more. So this is an example of last in, first out. Louise and Florence. Let's go in here and include our stack library. We can go and get the number of elements that we have. So let's go size, customers, and size. And there you can see we have 3 of them on there. We would then be able to check if we have customers inside of there. So we're going to say not customers empty. And then in a situation in which we do have customers that we can output, we can go for int I is equal to 0 while I is less than, and we'll use customer size and then increment the value of I. And then to get the top value off of it, we can say cout customers top. And if we would want to delete the values, we could say customers pop. And there you can see we have Florence and Louise print out. Remember, last in, first out, and then we deleted George. All right, so quick example of how to use stacks. And now I'm going to cover the first in, first out container we have available called queue. Let's go and create a queue. And this is going to be a string. And we'll call this cast. And you're going to be able to push values on here as well. So let's go and throw some random values on here. All right, so we got some random values. We can go and get the size for them. So size equal to cast and size. And we can check if they are empty or not, just like we did before. If not, cast empty. We could cycle through all of them. Int I equal to 0, I less than size 2. Increment the value of I. We can get the value in the front, cast, front, and we can also delete with pop. And come in here and include the queue library. Little error, make sure that you have size here, not size 2 like I did. And you can see we got our results like we expected. All right, and one more container, and that is going to be called the priority queue. And you know what? I'm not going to change much here. Let's go get that back. Let's just jump right in here, and I'm going to change this to a priority queue. Priority queue, and I'll just change this to integer, and I'll change the name to numbers. And then let's just grab nums, paste this inside of here, paste this inside of here, paste this inside of here. And this is just going to be an organization with the largest first. Again, we're going to use push. So I'm going to throw 4 inside of here. I'm going to throw 8 inside of there and a 5 right here. We can go and get the size just like we did before with size. I can check if nums is empty. Here I'm going to change this to nums, and instead I will use top and pop right there and run it. And there you can see all of them are in order just like we had said. All right. One more guy here that I'd like to cover, and that is going to be called the enumerated type. All right, so an enumerated type is going to be used to create custom data types. And what you're going to do is assign names to constant integers so that your program is going to hopefully be easier to read. So let's go and create an enumerated type. We'll go enumerated type, and we'll call it day. And it's going to be Monday equal to 1. And Tuesday, and everything else is going to cycle through. The value assigned to Tuesday is going to be 2, Wednesday's 3, so forth and so on. And there's Friday. And what we'll be able to do now is go enumerate and day and Tuesday and assign it to twos. We can now come out, cout, and say something like Tuesday is the, throw quotes around this, and then reference Tuesday. And then down here, say something like for second day of the week. And you can see right there, Tuesday is the second day of the week. Prints out. You're also going to be able to cycle through all of your days. So you could say for int I equal to Monday, while I is less than or equal to Friday, and then increment and print them out if you'd like. Or more than likely use them for something else. And there you can see it printed out all those values. All right, so real quick introduction to enumerated types. And now to finish off the entire tutorial, I'm going to talk about regular expressions. Finish up this massive tutorial, I'm going to cover regular expressions with a brief example. If you want more on regular expressions, I'll provide a link in the description. So of course you need the regular expression library. And basically what a regular expression does is it's a way of defining what type of information we want to search for, in this situation, in a string. So what I'm going to say is I'm going to say that I want to match, here's a string that we're going to search for, the apex. All right, so there's that weird thing. See if you can guess what I'm trying to search for. So then what we want to do is define the character codes I want to use to search for something. So what I'm going to do is I'm going to say that I want to look for the word ape, and also that I want to match for something that's not a space, or by putting that question mark inside of there, I can say basically I want to match for just ape. All right, so I want to match for basically ape with a space, so that would be this guy right here, or I want to match for ape followed by anything that is not a space, which is, in this situation, going to match for this. All right, so that's what that is. I know it can be confusing, and if it's confusing, like I said, look in the description and you can find out more about regular expressions. Then I'm going to get smatch, and this is going to provide all kinds of functions I'm going to be able to use to work in regards to searching through strings. And then what I can do is I can go regular expression and search, and you go str, the string I want to search for, matches, and then the regular expression. And I'm going to say if there is a match, which is what the first part is checking for, well, then I want to do some things. Well, what do I want to do? Well, one thing I'd like to do is I would like to output the number of matches, and we could say something like just matches. Now that we know that we also have matches, what I'm going to do here is I'm going to cycle through those matches and output some information on them. So how we do that is I'm going to say regular expression and search and string and matches and regular expression. And then what we can do is get each of the matches as well as the index. So we go cout and call matches and str1 to get to the first match, but we're going to cycle through and get the other one also. And then I'm also going to get the index for it. So let's go grab that, throw that in there, and we could say something like at index, throw that there, and change this to position. Let's go to the next line and position. Then what we need to do is after we get that match, we need to eliminate the previous match and create a new string to search for the next match. So string is equal to matches, suffix like this, str, and run it. And whenever we run it, you're going to see that we are able to get our matches, being 2, both ape, and then we also got the second one at index 12. All right, so there you go, guys. That is a lot of information on C++. Hopefully somebody watched it. If you did, well, that's absolutely amazing. And just like always, please leave your questions and comments down below. And otherwise, till next time.